My partner here is Miguel Elias Robles, and my name is Thomas B. Ricker. We hope to entertain you for the next 45 minutes plus Q&A. Okay, let's start with a small overview of the lecture. We'll just point out some basics. Sometimes we won't even go in depth, just point out what you should check to understand the further topics. And then we'll start with wartracking itself. It's just some history, what was in the past, what were interests on satellites in the past, what was interesting. Then present, which is more or less, we said 1985 to now, just to make a difference to the past. And then we'll consider what will be the future of satellite communications, what is interesting, what can we expect. And then we'll go on to hands-on wartracking. That's more the practical part, looking at what you can do actually, what you can listen to, that's passive, and where you can actively use satellites legally and illegally. That's the next point, legalese. What are legal implications of passive or active use? And then we'll end up with the Q&A session. Okay, so let's start with the basics. What is a satellite? A satellite is an object circling around another object, as opposed to objects that leave the circle around the object. That would be like Mars Explorer. That's not a satellite that left Earth orbit. Orbit is the path around the planet in that case. A geostationary orbit is a special case. The basic point is it's a very interesting orbit because you can use it for communication satellite. If you look at a satellite from Earth, it appears as if the satellite wouldn't move at all, because it's more or less moving around the Earth in the same speed, the same angular velocity as Earth turns. So every 24 hours it circles around once, so it seems to never move. Okay, ecliptic, another element. We'll just speed it up a bit. Keplerian elements is a thing you will be needing afterwards, after this lecture. That's the sum of all relevant variables of an orbit of, for example, a satellite, to know where it is. You can feed those Keplerian elements into a specialized software, and then it will tell you that the satellite is exactly over there. And then you know where to point the antenna or where to look. Some satellites can be seen from Earth. The most famous is the Moon, of course. Payload. Payload is, that's what we are basically interested in. That's the part of the satellite that is active, where, for example, the TV program is relayed from orbit back to you, to your home, to your satellite dish. Frequency bands used for satellite communications are, for example, the most used TV band is around 10 to 12 gigahertz, that's the Q band. And there's also C band around 4 to 5 gigahertz, more or less. You can find all those informations easily, for example, in Wikipedia. So it is not necessary to cover them here and now more. The transponder is a thing we should mention too. It's well, the logic element of the beam coming down from a satellite, for example. It's a part, a frequency band, where a special information is contained. For example, a TV program, or with DVB, a digital video broadcasting or digital data broadcasting. It's the complete multiplex containing all TV, radio, and additional data. Okay, so much for that little basic introduction. And now we're going on to, in medias res, to go to the past. That will be covered by my colleague.
Well, the first satellite, it's Sputnik. It was launched at September 1957. It was nothing else than a radio transmitter in 20 and 40 megahertz. It's really low in frequency. And it was really fast. It had only 6 hours, I think, to take around the whole world. And he only transmitted temperature outside and inside of the satellite and the pressure. Historical, you remember the Americans had a shock. Well, they said, they launched a rocket and they had the satellite on in orbit, and we can't, and why it doesn't. And the important thing in this is they launched the Sputnik with a standard atomic bomb, ACBM rocket. So they show with this satellite that they can arrive with their rockets America, and this was the important thing. I have a little audio recording of the sound of the Sputnik. Oh, sure. This was what you heard, 1957. This was temperature and something like this. So you can, in this frequency, you can hear it with a standard AM radio. So anyone in the Earth, and the moment the satellite overflow you hear this sound in the frequency of 40 and 20 megahertz. So anyone know that the Russians had a satellite above your head. Well, GLONASS. GLONASS was a satellite systems. They use it for reconnaissance, like they can make photos, really sharp photos. They said it was more for weather satellites, but I think no one believed it. The thing is, the last GLONASS satellite, 945, hit the ground and Canadian ground. So they found out they had an atomic reactor in it. So Russians shot satellites with atomic reactors in the space, and they didn't know that the satellite hit the ground. The Canadians called the Russians saying, "We have something from you." USA. Well, the first telecommunication satellite and, well, telecommunication and television satellite was a Telstar. It was something like a ball, nothing bigger than this. It was really unstable, and to make a connection, well, the American president wanted to make a television transmission to France. They had only a half an hour because the satellite overflew the Atlantic, a half an hour, and after this half an hour, it hasn't more. The satellite was anywhere, but not in Atlantic. And the funny thing is, it was really unstable. It was a ball, it making everything, but so this was the first video transmission from USA to France and from France to USA. Not really good. They had problems with NTSC signal. Never the same color. Well, something different, isn't it? NOAA. I think you know more about the NOAA.
Well, the NOAA are satellites, or basically some weather satellites by the NOAA, and they provide, for example, weather pictures and other things. Well, that's just to give some idea what's up there. There are other satellites like the GPS satellites by the US and things like that, and also other countries had their satellites too, military or civil use. For example, well, go on.
Well, the next country was France. France was one of the successors of Russian and USA. They sent the first satellite from Africa, I think. It's nothing special. They only had the satellite only was for to saying we have also a rocket that can reach the space. Japan was after this, after France, taking the first communication satellite for Asia. Well, Americans had the satellites, but they reached Japan, but that doesn't had Japanese programs. Germany had launched with the ESA some satellites, and UK. This is something special. They launched many satellites, but only with well, one of the satellites was launched from a submarine, and because they had the rockets and the submarines, and so it was possible. Present communication satellites. Your turn.
Okay, thank you. This is telecommunication satellites in the beginning of the period we took as past, that's 1985, were basically phone lines and television lines for transatlantic transmissions. For example, many phone calls were dispatched that way, and that was a very interesting period because all that comes were just multiplexed analog signals, so it was really easy to listen to that stuff. That was really interesting. You could find some really interesting information there. This is still true. There are satellites, for example, Arabsat, operating in the C-band, visible from Europe. You can receive it with around 1 meter, 1.20 meter dish with an low noise block amplifier for the C-band. And well, there's a transponder you can tune into, and you'll find there are still plain phone lines there, and you can listen to phone calls, trace them, see who called whom, and there's just plain in-band signaling by DTMF, and